Good afternoon, everyone. We're here today to talk about our research on lowering carbon emissions in concrete. Our presentation is Decarbonate with Kelpcrete, using kelp as an additive in concrete to lower carbon emissions by improving thermal resistance and embodied energy costs.
This is our research team. We are a group of students from California State Polytechnic University, Pomona, who are passionate about regenerative solutions for the future.
The world has a growing problem. The construction industry contributes to 40% of worldwide greenhouse gas emissions. Concrete alone contributes to 8% of these world emissions. Too much concrete equals too much carbon.
So what can the world do to lower carbon emissions from construction? Improving the efficiency of concrete will dramatically reduce the carbon footprint of the construction industry, pushing the world into a more sustainable future. Our solution?
Kelpcrete, a concrete mixture that replaces 20% of Portland cement with raw kelp powder or seaweed gel. It can be used as a substitute for conventional concrete to lower carbon emissions by increasing thermal performance and lowering embodied energy during production. It is made by cementing materials such as Portland cement and a mineral aggregate such as sand and gravel with sufficient water to cause the cement to set and bind the entire mix. This is our abstract from our research paper. Kelpcrete is a concrete mixture that replaces 20% of Portland cement with raw kelp powder. It can be used as a substitute for conventional concrete to lower carbon emissions by increasing thermal performance and lowering embodied carbon energy during production. Since concrete is one of the most widely used materials in modern construction, using Kelpcrete may dramatically reduce the carbon footprint of the construction industry as a whole, pushing the world one step closer to a sustainable future. This research found that the thermal performance increases as the amount of kelp additive also increases, and that the optimal amount of kelp additive was 20%.
So to kick off our research, we asked a couple of questions. For one, how does kelp powder or gel work as a substitute in concrete to begin with? And why use kelp as opposed to other organic substances like straw? What are the emissions of kelp and seaweed in the harvesting process? Where can we find kelp? Where is it a viable resource? And finally, what is the R value of kelp? R value being the thermal resistance value of a substance. And here are our research methods. To begin the experiment, we identified the carbon emissions of standard concrete. We then analyzed the density of concrete using different sized aggregates and compared that with the seaweed concrete mixture. Then, using traditional concrete products, including concrete block and poured concrete, we devised a formula to calculate the R value of mixtures of 10%, 20%, and 30% kelp. Lastly, we conducted energy simulations using software Opaque to identify how kelp alginate-infused concrete panels perform in comparison with standard wall assemblies using traditional building materials. Material composition.
Concrete mixture consists of three main components: aggregate, binder, and water, with the binder traditionally being Portland cement. Kelp is a natural polymer. This natural polymer can be used to substitute the binder of the concrete mixture. This polymer has great adhesion properties, which is the ability to stick or bind onto other surfaces. This is why kelp works as an excellent substitute for replacing Portland cement. And based upon an article, the effects of seaweed powder to the properties of polymer modified concrete. They tested different mixture proportions of seaweed powder replacing Portland cement, provided in Table 1.
Embodied energy.
This is you. And you are here. And that is the Empire State Building. By replacing 20% of Portland cement with kelp, the world can save 683 million tons of ice from melting per year. That is 643 entire Empire State Buildings of ice every year. So what does that mean? Kelpcrete can reduce concrete emissions by 18%. That's 1.5% of worldwide emissions. And let's break down the math here. Concrete contributes to 8% of worldwide emissions. Portland cement contributes to 90% of concrete's emissions. And if kelp can replace 20% of Portland's cement found in concrete, as mentioned in the research previously, and if kelp has the potential for net zero carbon emissions, which our research indicates on the harvesting process of kelp, then Kelpcrete has the ability to reduce 20% of the emissions that Portland cement contributes in concrete. That means that Kelpcrete can reduce the world's emissions by 1.5%.
Thermal performance. Thermal performance is the measurement of how well a material retains or dissipates heat and energy. In order to figure out how well our material performs, we needed to figure out the R value of Kelpcrete. This is the formula we derived to calculate the R value given a certain percentage of kelp additives. These are the results of our formula in action, using 20% kelp mixture. The R value increases compared to traditional concrete. This is the results of our formula using 30% kelp mixture. The R value increases even further compared to traditional concrete.
The R value of kelp in our model based on existing installation samples using opaque. These simulations are to show a kelp alginate infused concrete panel as part of a larger wall section and isolate its R value with other materials in this section. The figure on the left is 0% mixture at 1-inch thickness, which was the R value of 13.09. The middle figure is 100% lightweight concrete mix at 4 inches thick, and the R value was 14.62. The figure on the right was a 20% mixture at a 1-inch thickness, and the R value, which was the highest, at 14.86.
So to wrap things up, in terms of structural compatibility, kelp is a viable additive for concrete. The optimal mixture was determined to be 20% kelp powder in the mixture to maintain structural integrity. In terms of embodied energy cost, replacing 20% of Portland cement in concrete with kelp powder lowers the carbon emissions of concrete by 18%, and by extension 1.5% of the world's carbon emissions. And finally, the research has also shown that the greater the amount of kelp gel and kelp powder added, the overall R value increases, therefore lowering the amount of energy required to maintain optimal thermal comfort in buildings, further reducing carbon footprint.
We would like to give a special thank you to the Center for Regenerative Studies and Dr. Carbon for being our mentor and advisor.
Thank you for watching our presentation. Any questions?